layer, and we attach this header to the message. This is the Internet Protocol header for version 4. We have, as soon as we attach this in front of the message, it is now called a packet because it contains the Internet Protocol header. So what does this header contain? It contains a number of fields. We have a 32-bit scale at the top. The most important thing that it contains is the IP address, which is the 32-bit address of the sending machine and the 32-bit address of the receiving machine. This is for IP version 4. So the addresses are 32 bits long. This is what we've seen earlier in the exercise. Other fields that it contains is the version, which is that first field. It takes 1, 2, 3, 4 bits. It will specify either version 4 or version 6. Right now, we don't have any other versions. Version 5 was just a prototype, so it never made it into a real protocol. So the next real version we have is version 6. So we have version, we have the next field that we have is header length, IHL. This will tell how long is the header in 32-bit words. We have another field called differential services. This will tell the type of service that we're using for this packet. This could be a combination of speed or reliability. There are some services that exist which are faster, but they're not very reliable. And then we have slower services that are guaranteed or reliable. So depending on the application, we could use a different type of service. Total length is the length of header plus data. And this optional part can vary, so the lengths are specified here. Then we have identification. This is to identify which packet a particular fragment belongs to. So all the fragments which are part of the same packet or data stream would have the identification number the same. And then we have a fragment offset. So let's say we have a big message that is too big to pass through a particular network. So we have the network layer, because it's dynamically adjusting to properties of all of these packets have to go through might break the packet into pieces. So once it does that, all the pieces of the original packet would have this identification number the same. And then the fragment offset will tell where in the original packet this fragment belongs to. Is it in the beginning, is it in the middle, is it in the end, or where is it? Fragment offset. Because what did we do here? We said the receiving machine takes the pieces and assembles them into the original data stream. So the receiving machine needs to have some way to reconstruct the original message after it was broken into pieces. And the way it does that is by using identification and a fragment offset. We have two bits, DF bit, which stands for do not fragment. If this bit is set, we're not allowed to fragment the particular packet. And more fragments means that there are more fragments on the way. If this bit is set, it means we have more fragments coming that are part of that particular packet. If not, this means this was the last piece that we're waiting for. And then we have the time to leave field. This field is set to a specific number, which is usually 255 seconds, and is decremented at every hop that this packet goes through. Why do we need this field? Why is it important?
Because like whenever we send maybe packets, it maybe needs to like reach the destination, right? In certain time it cannot reach the destination. Maybe it's just drop down. I'm not sure.
Right. If it doesn't reach, did you hear what he said? If it doesn't reach the destination within a particular time frame, the packet is discarded. So basically this field gets decremented at every router that the packet goes through until it reaches the destination. If it goes to 0, the packet is discarded. This feature prevents packets from getting lost on the network and wandering around the network forever. Next we have protocol. So remember that the job of network layer is to provide service to the transport layer. So once this packet is received at the destination machine and the pieces are assembled together, this is given up to the transport layer on the receiving machine. And so the transport layer on the receiving machine is running two different protocols. It's a transmission control protocol or a user datagram protocol. So this field will specify which of these two protocols to give it to when it's received. And the last thing that we have is the header checksum. This is used for error detection and correction, so to check whether there are any errors in this particular packet. The options field at the end is a variable length. This was left with regard to future works. So it was allowed to provide some options for future use and also for backwards compatibility. Yeah.
There's like one bit, right?
Mhm.
Blank bits.
Yeah, there is a black.
So why do we need that?
You don't. That's why it's black.
It must be some purpose, right? If we don't, you don't need to put it over there. There must be some purpose. Put in.
This is to kids.
No, I don't think so.
It's not used. It's not used, so it's grayed out. They didn't find any purpose for it, so just sitting there.
So what about like destination address? How do we figure out destination address when we send packets from source to destination?
Okay, this is like the label on your post office package. So think about you're gonna send a package in the mail. So attach a label to it that says this is the address of the sender, the person who sent it, and this is the address of the receiver, the person that's supposed to receive this packet. It's a package with label. The same thing here, it's a package, and this is the label. This is the sender, this is the receiver. So basically the destination address is written on the top of the package. Right?
It's
Right here. This is the label for the package. And then the package is underneath.
but we don't know the destination address, right? As a human. That means program automatically knows the destination address, or
Oh, are you asking how the computer gets an address?
yes, destination address, and send it to the destination.
Okay. So every computer or every host, router on the internet has an IP address. If it doesn't have the address, it cannot be on the internet. That's basically what happens when we sign up for internet service with the internet service provider. What do they provide us? They provide us an address. They give us the address, the IP address. So they assign an address to our machine, and this is our address. That's the source address, if we're the sending machine. The receiving machine, the same. They obtain the IP address from the internet service provider. Now, there is an international authority that regulates the IP addresses. So it decides who gets which address, and that authority makes sure that every separate machine or device that's part of the internet has a unique address. So let's look at that.